Hello everyone, let's wait a few more minutes until everyone joins us and then we'll start. Okay, hello everyone. Let's start our today's session. Today we're going to continue about talking about object-oriented programming. We started last time. The topic is very important, so let's move on. I already shared the materials we'll use today with you. There's also one additional PDF file. We will jump to it as well today to discuss more things about object-oriented programming. And you can start at 14th slide there. As you remember last time we started talking about classes, about object-oriented programming, and as you know, we already before the previous session we used reference type variables like strings, remember arrays, remember integer class, string class, scanner class, and so on. All these objects and classes. We will also need to distinguish them. If we talk about scanner, let's for example talk about scanner when we create scanner, that's the object. And when we create the variable with the class, that's the object. When we just use the class like integer, that's just the class, that's not the object. But if we declare the variable with the type of this class and we actually create the instance of this class, that's the object. So we already even before we used reference variables, we use classes. We actually everything what we did using the classes. When we create new file, we actually create new public class. So as you understand that we already used classes for many times and with many different usages. As for example, the arrays are also the reference type variables. So as you know, the arrays that's the set of the values that's actually the variable which stores the values with the exact type. Like again, as you remember, the arrays of integers store only integer values. So we have a set of values. That's also the object. And arrays are also referred to the class. And remember, we can do some things with the arrays. We can get the length, so that's the attribute of this object. Resolution. Thank you very much. Thank you. Moment. Sorry, I just. One moment. It's actually fine. Okay, so as you remember from for the arrays, we can do some things with the arrays using just using the array variable itself. We press dot, or we type dot, and then we can call some methods, and we also can get the attribute. So using the length, we actually get the attribute of this object. And object is array. So that's what we already done. We already used, and the same way as for the arrays, classes, different objects are declared and are used. we'll see how. And also, of course, the string. For the string, we had even different topic, the separate topic for the string. And as you remember, for the strings, there are lots of different things we can do with them. Remember all the methods, yes, the special methods meant for the strings, char, add, and so on. So these are the methods which belong to the object, belong to the string, and based on the content of the object, we actually have the objects of the strings, which are, as you remember, the references to the memory. And under these references we have the content of string, and the content of string is actually the set of characters, as you remember. And all the methods we have here actually deal with the characters located under the string object, string reference. And so that's so using the strings, as for example, you can get the first understanding of the concept, how the objects are built. So we have the variable, we have the attributes. So we may assume that under the string objects, as the attributes of the string objects, there are the characters located in the array way or some other way. The attributes are located under the string object. If we have different strings, string 1, string 2, we will have the same class for them. The class is string, but both strings will have different characters assigned to them. So actually the class will remain the same. The class is string, but the object properties are different. The characters here are different. That's why all the methods here for different strings, and for all the strings you can call these methods, but they will give you different result based on the properties, based on the attributes. Basically, the only attributes which are assigned to strings are basically the character set of the value of the characters. That's why, based on these attributes and based on characters, the behavior, the results on these methods under the string will be different. And the same concept can be applied for all the objects, for all the reference types in Java. And not only in Java, in general, in all the other programming languages as well. Except maybe a little bit for scripting languages. Scripting languages use a little bit different concept, but that's not our case. We talk about more classical way of scripting languages are more modern, more new approach. They use new approaches, and if we talk about scripting languages, these languages are JavaScript, most popular are JavaScript and PHP, and maybe the more classical languages are Java, C++, C, C#, and so on. So you see there is mostly C++, C#, and Java. These languages use standard approach, so most of the concepts are the same, with some differences, especially related to the inheritance. We'll talk about it, but the main concept, again, the methods, and that we have the methods, we have the attributes, so all these things, and we have the type, we have the methods, we have the attributes, and we have the type of the class. So this is the same in Java and in C++, for example. So already, so that's just an introduction, but we already work with the classes, with the objects. So that's basically there's nothing 100% new here. But as you remember last time we already worked with strings, we already worked with arrays and writing scanners and other types. But for now, so our current topic will be to create our own classes, our own hierarchy of the classes, which we can use. So and last time, as you remember, we talked about the computer. we talked about the computers. So we talked about the computer as the class. So that's the idea is that we have the class of computer, and so for all the computers we have some common attributes, common properties. For example, the weight, the RAM memory, screen size, price. All the computers do have these attributes. I mean, of course, we can talk about. I mean, that's as an example. As an example, we talked about the class of the computers, where for each of the computer there's the weight, there's the RAM, there's screen size, and the price. So basically, the idea is that these are the common properties, common attributes for all the computers. I mean, each computer should have. In this example, each computer should have all these attributes. So this is what we know, and this is what we can use. And the idea is that, so just to use this class for our needs, and so if we want to process the data about the computers, we can use the class computer for each computer separately, and then we can actually do our stuff with all these attributes, and using the methods we can process the information we provide to these objects. And what we did here, as I already mentioned, we created the attributes, and comparing to what we did before this topic, we usually just created static attributes. That's because we haven't worked with object-oriented programming yet. Right now, since we start working, we can also declare non-static attributes, and these attributes will be used for the objects. So again, the first thing to understand in the classes, static attributes are used for the classes, so we don't have any objects, and the instance attributes without static keyword are used for the objects, which are referred to the class. To the class they are declared in. So that's about the attributes. Attributes define the properties of the class. So each computer do have these properties, but actually the values of these properties will be different for different computers. That's obviously. And comparing to this, that's maybe the first thing to understand, and for you to will help you to understand what's the main difference when we need to use static and we don't need to use static. The first example for you will be that again, for the objects, for the computers, we have many computers, and if we create the object, we create first computer, then we create second computer, we can assign different variables, different values under these variables. And so for first computer we assign the weight, the RAM, the screen size, the price, color. So these attributes will be actually under this object. The same is for the second object. For the second computer, we create the object, then we assign all the values, all these values. So then the second computer will have different values of these attributes. Comparing to the static values, static value, if we assign something to the static variable, this will belong to the wall class of the computer. So it does not belong. It will not be different for different object. This is because this is the part of the class. This will be the same for all the objects. And we can actually already check it here. Let's quickly check it. Comment out. And yes, for example, I'll also comment on the actions because we will not talk about the methods at the moment. So here we create. So right now we'll create two different computers, and we'll see what's the difference between static and non-static attributes. Right now, please note that we have one static attribute here and some non-static attributes. So first of all, we create new object, new computer, and I define it as the first computer. The same way, we can create the second computer, and we do it the same way. We call new operator. New operator actually creates the new object with the instance provided here. So here we create another object, and the first below here we have the first point is we have one class and two objects. Two objects referred to the same class. Same class. So that's also the main difference between static attributes and all the static things comparing to the non-static things. For static things we have one class and that's it. For non-static attributes we can have multiple objects. Alright, so here as you can see I assigned the values, and right here I will assign just different values for the second computer. So, write a comment. Assign the values to the second computer object. So let's do it. Color will be yellow, and then same price. So what will be something like 700. Then memory will be 32. Then it will be screen size 13. And I'll also assign new bake to the computer. It will be the same, for example. Why not? So okay, right now I have two objects, and each object has different values. So what I can do, I can create a new method here which will display us all these attributes. So that would be the first task, the first meaningful method here. I will which displays all the attributes of the object. So yeah, one maybe not disadvantage, but one thing which is not comfortable for us to use is that by default, yeah, when you create the class, then you have kind of attributes of the class. Then it is not actually possible to just easily, like with one click, print them out. To print them out in one action, you will need to create the method which will do it. So let's create this method. Display attributes. The same as for the arrays. We don't have the exact method which will print us all the attributes. We need to all the elements of the array. We need to create our own method or use just search something in different classes. But actually, it's not possible to print as system out print object. This will print you the reference. It will not print you the values of the object. That's why we need to create a separate method and define the output. So here I will print out all the attributes. Print out all the attributes. Yeah, first attribute is color, and color we can access color two equivalent ways. So but actually we can do it this way. We can write color. This will be the attribute name. More precise way would be if we type this and then write the attribute name. What does this mean? We will we'll talk a little bit deeper about it, but it actually refers to the object we are currently in. Yeah, if we talk about the object we declared here, so here we access the object using the variable name, then we access the attribute. Using this keyword, it actually means that this is the object we are currently in. Yeah. So as you know that if we call the method right here, we call it from the variable. So when we are in this method, we have the variable, and using this variable we access the object. When we are inside the object, so when the method is called, we are inside the object. So here we are inside the object, and inside the object, to actually from inside the object to refer to the object we are currently in, we can use this keyword. So maybe I'll type it here. We'll talk separate about it, but just right now, this keyword, it is current object we are currently in. So the same way as this is the variable, this is the object, this is also the object. So in fact, when we call this method from this variable, from this object, in this case, this and the variable from where you call this method, actually these are the same. These objects are the same. These variables contain the same object. So if we call display attributes from computer 1, then this will be the same as computer 1. When we call it from computer 2, then this will be will have the same, this will be the same object as the one assigned to this variable. But we will talk separately about it later. Let's just not confuse you since I use this here, this keyword here. Alright, so let's continue printing out all the attributes. So we printed out the first attribute, then let's print out the second attribute, price. Then again I will use price. So yeah, basically don't be afraid if someone does not use this. That's also a fine approach. So you can skip using this. The result will be the same. But with some exceptions. And the exceptions would be if you declare the variable with the same name. Yeah, like so just if you declare a new variable, the same variable here, the variable with the same name, price. I will send the value for this. So in this case, if I declare the variable with the same price, then price will not be considered. This variable will not be considered as the attribute of the object, but this will be considered as the variable you declare here. So if you declare, maybe I will comment it out and then comment it out and type it as an example. Example below. If you declare the variable with the same name, as the attribute of the class, and then inside the method the program will use the variable you declare in the method. So this is basically the only exception. Yeah, if you declare it in the method, and also if you declare this attribute as the parameter of the method. Yeah, so if you declare it here or here, then it will use the variable you declare. If you don't declare, then there's the same. But it's one exception. And that's just for your understanding. With some exceptions. Okay, I already mentioned here. Okay. Spaces. So yeah, that's why just to be 100% sure that you don't confuse that the program will use the same variable. If you use this, the program will always understand what you want from it. That's why I usually but almost always use this keyword. And from my point of view, this is always much more easier to read the program. So if you type this, you refer to the attribute. So when I read the program, I can quickly understand that this is the part of the object we're currently in. Okay, so the next attribute is RAM memory. Then we have screen size. and we have the weight. Alright, so right now the program will print as right now it won't print just maybe for you to understand. Let's run this program. Sorry, that was accidentally cancel. So just missed the button. So cancel. Okay, let's run the program, and we can see that we have no output. Yeah, can you understand why? Yeah. So your idea is why the output is empty here. So we actually what we done here, we just assigned the values to the attributes, but what we haven't done here yet you can see the code. Yeah, we did not call the method. Yeah, that's for sure. So that's why we define the method. So right now we are ready to use it, but we haven't used it yet. So right now we can call the method, and we can print basically we can print the content of the objects, computers. Alright, so first of all, let's print out the first object. The method from the first object, computer. Yeah, I created the separate print here just to distinguish which computer is printed. Computer. The method was display attributes. Display attributes, the same as for the second computer. We call it the second object. And too long text, but okay. Let's see. We actually have one method. We have one method here with the exact object. But what we have in the result, okay, maybe let me print just one empty line. Just put them, just put them. So just to have this empty line. So now we can see two objects here. We can, as you just seen, we have the same method, with the same object, but actually the output is different. Now the output is based on the attributes we have under this object. So, and this is the key. Actually, this is the key thing of object-oriented programming. Yeah. So that's we have the logic, which is behavior, based on the object, based on the content of the object, and the content of the object is these attributes. So two different objects. We have the output of the same method. Same method is different. Yeah, that's the same if you, as you remember, if we run the program, we pass the attributes, then the output of the program will be based on these attributes. Something similar is here. We provide the attributes, and we create the objects. First of all, we create the objects, then we provide these attributes to the objects, and then based on the values of these objects, of these attributes, we'll have different results in display. In this case, display attributes method. In general way, again, we can have the methods where some calculations are done based on the properties of the object. So that's why the conclusion for this this printing is that we actually have the same logic placed in display attributes method. But the output is based on the we can call it differently. Content properties. I hope you understand that content properties. That's the meaning is the same. For in our case, that's basically what is assigned to the attributes of the object. So the output is based and it can be different objects. And one more thing. What we will do here is we'll print one more attribute. And what we can do, so what will be the attribute routines for the static? Maybe I will. Maybe let it be just something like model. Then so in this case I use static attribute, not instance attribute, and we'll see what will be the difference here. So first of all, for static attributes I cannot use. In fact, maybe I can use, but actually this is a little bit crazy, and in different programming languages that's not allowed actually. In this case, I can use this model, but we'll see the difference. I can use first of all, you can see that this font is different here, and one more thing, that compiler shows us the warning, and that's basically what I talked about. Actually compiler will allow you, but it's not recommended. And what it is said here, the static field should be accessed in a static way. That's suggestion, and that was what I said, that Java will allow you, but it will complain. But so it shows that we can please I'll write it this way. Java asks us to not to access the static tree using this keyword. That's because from the logical point of view, that's incorrect. and when we, yeah, maybe let's keep it and we'll see what we'll have in the result. Yeah, I will assign it here. And I'll type something like model 1, and that's just for understanding, and then for the second computer I will type, let's see, model 2. And let's see what do we have at the result. First we have the warnings, but we'll see why we have them. So yeah, what we can see here, you see, so that's basically the main difference between static and non-static attributes. We have, actually, despite the fact that we assigned, here we assigned model 1 to the model attribute, here so it prints, even for the first object, it prints model 2. So can you guess why? And that's also the part of the concept of object-oriented programming. I think I mentioned it, but we'll talk a little bit later about it as well. But from your point of view, can you understand why do we have such output, that model 2 is printed even for the first object and for the second object as well, for both objects? Model 2 is printed, despite the fact that here we assigned model 1. Can you guess why? Yes, model was static. Yeah, that's correct. That's correct. And so I'm asking more about the reason why the output is. Yes, that's a very great point. Yeah, static attributes are the same for all the objects. So that's what I mentioned, and this is basically the key concept of the difference between statics and instance attributes. So yeah, in this case, I will. So how can I describe it better here? Let me see. Yeah, maybe I will do it this way. Yeah, first of all, the syntax is as it says said by Java. Don't do it. Yeah, that's and this is basically this is why Java complains, because here we try to right here and here as well, again, because as I said, these are the same cases. When we actually access the static attribute from the object, we should normally, and this is what is correctly mentioned by Natalie, we should normally access static attributes only from the class, not from the class, but to the class, yeah, from the class. So we need to type the class name, then we need to type the model name. So this will be more, actually the result will be the same, but the way will be more correct. That's because, again, as it stated by Natalie correctly, when we access static attribute, we actually access the attribute which belongs to the class itself. It does not belong to the object. So maybe I'll print it. I will comment it, but so I'll type the comment here. This approach will be compiled. And there won't be any errors except the warnings. Yeah? Except the warning. But the way below is the way, this way is not quite correct. Way is quite correct because we need to access static next line, because we need to access static attributes from the class, not from the object, because they belong to the class, not to the object, because the static attributes belong to the class, not to the object. Yeah, that's why this approach, but actually the result will be the same, yeah? But actually the result will be the same. Same if we access from the object. This way, this way. The result will be the same. And the same is here, yeah? So if we comment it out, then as I stated here, so if we comment it out, we can actually see that we changed the same attribute right here. So in this case, this will be changed here, but it will also be changed here. So at this point, when we print it out, the attribute model will have this value, not this one. This value will not be used anymore because we assign it here. So since we assign the new value here, the previous one will not be used anymore. Not used, but will not actually will be, this previous one will be replaced. And here you can actually see it more precise way. Why do we have different value, different value for the first object as well? And the same here, if we correct as it stands by Java, as it stands by Java, with and again for static attributes, remember that we can access them without mentioning the class, but the issues, not the issues, but the complicities will be the same as if we access without this keyword. And the same for the static and for the reference attributes, we can access them without this or the class name. But again, if we have the attributes with the same name defined inside the methods, then even if we don't type the attributes, then don't type the keywords here, then the program, the method will use the attributes defined inside the method, not from the class or from the object. Yeah, that's why that's the same as for this. I would recommend, and I usually try to stick to this approach, that I use class names, so it's again easier to understand what we actually want to achieve. So yeah, and right now here we can actually see that there's no mentioning that model attribute belongs to the object. So yeah, we have no assignment between the object and the value. And so here we access it using the class name, so there's actually no object we access it. We use the class to access it, and the same here. We don't use the object to access this attribute, we just use the class. And that's why, some final comment I'll type here. Since as we can see here, attribute model is never changed from the object, and that's why it has no dependencies on the object properties. So that's actually the thing. But what we can see here, actually the output here is dependent, and the last thing is dependent on the class attribute. So, and that's also the part of the hierarchy. Static attributes, the only concept where the static attributes can be dependent on the instance attributes is where we have the array of the objects. For example, we can have the static for each class. In theory, we can have the static array which contains all the computers. If we define it this way, static computer. Array. So if we have the array, then in theory we can put all the objects in the. So we create the object, we put it in this array, and if we use actually these objects, in theory, of course, we can create dependencies on all the attributes, not all the attributes, all the computers located in this array. But that's maybe more specific case. In general, if we don't have such tricks, then object behavior and object attributes can be dependent on the class attributes, but the class attributes is independent from the object attributes. So the object's attributes should not normally affect the class attributes and the behavior of the class methods as well. Okay, right now let's have the method. Let's have the break, and after the break we'll continue discussing. If you have any questions during the break, please write. We can discuss them after the break as well. Okay, let's move on. So yeah, that was the introduction about static and non-static attributes. Basically, the approach, the content we just the concept we just used for the static and non-static attributes can be applied for the methods as well. Like if we call the method from the from the object, this will actually be the instance method which belongs to the object. To the object. The static methods will belong to the class not the object. So yeah, that's basically the concept. This is the main difference between the statics and non-statics. Again, the first statics belong to the classes, and non-static belong to the object. Okay, so now let's I will open the PDF presentation and share with you. There's also an introduction about object-oriented programming, but yeah, I think that these things also help to describe why do we actually need the object-oriented programming. So if we talk about just simple way of coding, you have some things to print. For example, you want to calculate some values, then print them. Of course, if you do only such this stuff, okay, for you that may be the question, and I understand this thing that you just may ask, why do we actually need all these objects, all these classes, when we can just simply write the code just line by line and don't go inside such complicated things like objects. Basically, the problem may be, we'll actually see how does it look. So first of all, again, we can have the baby. Then the baby also have some attributes, name, sex, range, and so on. Then again, if we define all these, if we define the class baby, then we define the attributes inside this class, and like string, boolean, double, and so on. So we have all these attributes which help, which actually describe the baby as the person, as the object. So this is, but actually, if we don't use the classes, so if we have, like, for example, two persons. So if we don't use the classes, what do we actually use? We actually define the same, not the same, but yeah, kind of, yeah. Actually, we define the same properties twice. If we have 2 objects, but imagine if we have 10 objects, that's the absolutely normal case. And if we have 10 objects, and for each object, if we define just the set of attributes, then imagine that we have, first of all, if we have different names, that's a little bit makes sense, but actually, if we have name Alex, why do we need to assign the value if we already know that this is Alex? It's not, nothing else can be assigned to the name Alex than Alex. And the same is for David. And imagine if the name is repeated, if we have 2 Davids or even more 3 Davids, then at the end we'll have just all these variables, David 1, David 2, and this would be the completely mess, as you may understand. So in this case, of course, that's not the practical approach if we don't use the objects. Of course, and another option would be if we use the arrays, but again, in this case, imagine that we we use the arrays. We store all the names inside the arrays, but what should we do with the attribute, with other attributes which is assigned to the name? Okay, we can create, in theory, we can create multiple arrays. Why not? We can do it, but again, imagine, but that we need to link the name with the weight, and if we have more attributes, then we need to link all the other attributes as well. So as the but again, the question is how can we link them? Of course, we can create multi-dimensional arrays, and actually each dimension will be responsible for the corresponding attribute. But first of all, first of all, again, in the array, we can have we should have the same type for all the attributes. You cannot create multi-dimensional array, then just have different types for different dimensions. That's something unreal. And if you have like 10 attributes, then if you have 10-dimensional array, that would be a little bit like suicide, I guess. So that would total mess. If you have the array with 10 dimensions, then imagine how you would need to access it. Like if you have array, first of all you need to declare it like something like that. Then if you try to access, then you will also need to access. And you will need to access to it like using something like that, and so on and so on. So imagine that's not a real practical thing to do. But actually, so the option to escape this, to use the same structure for the similar classes, similar structures, like again the person, the baby. That makes sense. If we can use the class, we can create the objects under this class, and actually deal with all these values. As an example, I can mention one code I just recently written. For example, so this is the logic I created some time ago. If we have, so this is the class, the program, which I run, and in this program, the program reads CSV or XML files. So in this case, there are the files, and if we have multiple files which we read, so we have multiple files. Each file is considered as separate object. So we have one file, we have another file, and all these files are actually the object, and each file has its own content. So imagine the case we need to process, like we have the folder. As for example, the simple example would be we have a website. For example, we have the website. We have it's like e-commerce. There are the products under this website, and so for example, we need to put all the objects, all the products from the CSV file or the XML file to the website, to the database of the website. So we need to, under the CSV file or under the XML file, we will have the list of the products. And again, we can have multiple files as well. We can have, first of all, we can have multiple products. So again, I'll show you one example. I'm currently working with as my separate project, the individual project. So I have a website, and then under the website I have the products. So each line is just a separate product, and so the task for the program, the task is to actually read the content of this in this case that's Excel file, if I convert it to CSV, then the content of the CSV file to read each line, and then each line will be processed. So in this case, if I read each line, I just need to store each line somewhere. And of course, each line can be considered as the object. So we have each line is the object with the content of item code, item label, item type, and so on. And so each line has the attributes. Each line can be considered as the object, and we can process each line as the object using Java, different programming languages. Basically, the concept is the same. It's Java or not. So that's why we need to use the object. And this is basically what is said here. If we have 500 babies, then imagine if you declare all the variables, that's a not efficient way to proceed. So that's what I wanted to mention here. And okay, let's go back to the presentation. Let's go back to the presentation. We discussed the classes, and we already talked about, and maybe yes, as you can see, the private attributes I mentioned here. I would also like to talk about access modifiers. As you remember from the last session, I already mentioned to you about access modifiers. If you scroll a little bit up in the chat history, you can see that I shared the table with you, where you can actually see what each access modifier allows you to do. So that's also a really interesting topic, and the topic is called maybe if we go a little bit ahead, it's almost here, so we already talked about the object. So we know that there's the object, we call each object as the instance, so that's the reference to the memory. So the program creates the reference to the memory, and under the memory all these properties of the objects are stored. So that's individual and different from the other object of the same class. We already know each object has its own attributes, its own properties, so the behavior may be different. They share actual behavior, but the behavior is maybe dependent on the attributes, and that's why it may result in different behavior. And object consists of specific values for the class properties, and object may call the class methods as well. So that's now we can call the methods and use the attributes. And you already know the difference between the class and the object. So we have the object is actually the instance which we use. The instance. So actually, when we create the object this way, so this is the object. And this is the object, and this is the class. And so the class is computer, the object is computer1. So once the thing is that once we create the object, we can use all the non-static attributes, non-static methods. For the class itself, we can use only static attributes and static methods. So these basically are the differences from the theoretical point of view. Yeah, from the practical point of view, they may be some. Basically, if you have some, for example, methods, methods may be, again, as we already know, the methods may be static and non-static. Static methods, so if you think about if the method must be static or non-static, then first of all you need to understand if it has any dependencies on the attributes you have inside the object. Yeah, first of all, also you need to think about the usage. Where do you want to use the method you create? If you just simply want to use the method as something to call it without even the object, then without any object, just call the method, calculate some value, and based on what the properties you pass to this method, then the static approach would be better, and you don't need to use instance methods in this case. If on the other hand, if you have the object, you know that you have some dependencies, like in this case, we know that for each object we have the attributes. We can have the attributes, and then if I want to print these attributes, of course I cannot use static methods in this case, because again I have instance attributes, so I need to deal with instance attributes, and basically the only way to deal with instance attributes is the instance methods. So we can only use instance methods inside the class. Inside the class we can use only the instance methods to work with these attributes, because they belong to the instance, belong to the object. So, and if you know that you have some dependencies on these attributes, then you need to declare the method as the instance method, non-static method. So that's the difference. And right now, as I already mentioned, now we will talk about the encapsulations. So what's the encapsulation is? As it stands from the name, you have a capsule. You want to put something inside the capsule, and in this case, that's as it stands from the definition, is bundling of data with the methods that operate on the data, or the restricting, or of direct access to some of an object components. And that's maybe go a little bit here ahead. As an example, in Java and also in all the other, most of object-oriented programming languages, there are access modifiers. As we already know, access modifiers private. Currently we used only none, just default. If we don't have, not here, sorry, right here. If we don't have any access modifier, it is considered as default. So maybe let me create access. So let's do in the way that I create the class here, and this class will only be used. I'll type it here. The public class here will only be used to show the things placed in this file. In the file, I will define another class here, and I will just use it. That's only because since I just want to split the files in the way that I have file which actually has some header, some topic, and the topic is access modifiers, and to have a meaningful usage of them, yeah, that would be crazy if I use the class access modifier, then I create, for example, create the object access modifier, so I create the object, new access modifiers, and that would be a little bit crazy, because yeah, what's the object of access modifiers? That doesn't make sense that I have object of access modifiers, and that's why that's better if I create a new class with some meaningful name and some meaningful approach. So as for example, let it be class user. Okay, imagine we have the user. Yeah, we have the user, and for the user we can have the username, which may be public. Yeah, we can define it as public. Public string, that will be username. And private one, let it be password. So yeah, we have the name, we have the username, and we have the password as the part of the object user. So in this case, what I can do, I can yeah, first of all, let me create the object. Then I'll create the object, which is something like my user. Create the user, and what I can see. So first of all, I can access username and write something. Username. I can access it and change it. So if I want to do the same with the password, I cannot do it. Yeah. So something like that. I cannot access it at all. So I cannot read it. I cannot change it. So basically I can do nothing with it from outside the class. That's because it is defined as private. What I can do, basically I can use this attribute only inside normal. Yeah, I can use it normally only inside the class, and this is what I will basically do. What I can do, I can have the public method generate password, for example. Generate password, and here maybe we want the password to be integer, so just that will be easier for us. And here I can generate the password. Yeah, I can use the variable password, the attribute password inside the class. That will be correct. I can use smart class. And here I can generate a random number. Randomize it. Okay, maybe let's use the double. Just double password. So let's use double. So now I can generate the password, and from here I can generate the password. So I use my user. I call the method generate password. Password will be for example. And maybe let's have the password. Okay, let's go back to integer. We'll see what we can do. Just a minute. Let's create it more simple. And we'll see why. So it will be from. Let's have it from 1 to 10. From 1 to 10, and as for example, yeah. Now we have the password. Now we have the password, and for example, again we can use scanner. This as an example. We can use the scanner object. Scanner, and then we can read password. We can enter the password, then we can read using the scanner. String that will be pass entered. And then we can read it from the console. And from here, for example, we can check. Okay, also it's call scanner, and here we can compare with the password enter equals. Oh yeah, we can clarify it using. Using the method here. Again, I can use this method, and I will just create method check password. Check password. I can pass the attribute, the string, the password I can compare with, and then I'll pass the password and something like that. And so here I can check if password equals the password generated here. Then I print something like password is correct. Otherwise, password is not correct. So it's the oh yeah, it's not string. Okay, sorry, let's not use string. Let's use integer. Let's see what this. So just forgot that we use integer. So let's parse the integer. So in this case, as you can see, we have the class integer. Yeah, we have the class integer, and we have the static method parse integer. That's because in this case we just have the method to which we put the string, and it returns as integer value. So there is no need to have any object to be used under integer. We just have the method to which we pass the value, and it returns as another value. So there is nothing related to any integer object referred to this class, just the method. So that's why it's static. So we have just static method, static object, and the static result based on the attribute we provide here. Yeah, and in this case we don't need to use the method equals, just just a comparison operator. Alright, so, and right here we can validate and check the password. And let's guess the password. Oops, this one. Oh, sorry, I forgot to ask user to write the password. So let's print it and let the password be print line. So print line, not print. Before password is not correct. So since this is random, it's not correct. At some point this will be correct, because this is random algorithm. So in this case, actually, from our main program, we do not see what's the value generated here, because we cannot change it. We cannot read it. So the only thing we can do is actually to guess the password, because this is random. So we don't have direct access from our main program, only from inside the class. So that's the example where we cannot access. Maybe in this case that's not quite meaningful example, because we just generate the password here. But again, the concept is that the program should not allow you to directly change the password. Of course, for example, maybe if we don't want to guess the password from the main method, I can just the approach usually used. So if we have the private attributes and we want to display them, sorry, it's the public methods. So we can we will define the method show password, and this will print us the password. Password is so, and if we put it, let's comment out scanner because we won't need it at the moment. We can show password. Let's comment out the scanner. So right now, it shows the password. The password is one. Sorry, something. This one. So, what is always? So this one. So what have I missed here? Okay, but that's not the point. What I want to say here right now. What I want to say that from the main program, from main method, we can read the value, but we cannot change it. So let's add the comment here, and this is basically the main purpose usually used for private and protected methods, that the access is restricted. So we restrict the access to the private attributes, and even more methods, yeah, that also can be the point. Let's use this example, to not allow the values to be changed or impacted directly from the other classes. And as an example, what I would like to so right here, what we as an example, we can do it different way. And after this, I think you will better understand the cases when we need to use private attributes. Yeah, maybe let's use the same thing like user and yeah, user, and let's enter the password. So to enter the password, we can create the method, the public method, which will allow us enter the password. And for the password, yeah, let's imagine that we have one restriction. For example, the password must have the length which is greater than be, for example, just two characters, 2 digits. 2 digits. So in this case, of course, yeah, let's enter the password here. Sure. So what does it mean that the password must be must have at least 2 digits? It means that if, for example, password is less than 1000, so the password is less than 1000, then we print out the password is too short. Otherwise we can assign the password provided here. Yeah, just a small example. And let's go back to the scanner. I will not show the password. I will not. I will use the scanner. Write the password, and I can. I can enter the password. So if I run the program, I write the password, and if I write something like, not 1000, but 100. Yeah, let me 100. Have 2 digits. Want to have 2 digits. So if we type something like 34, then it shows that the password is too short. If we oh yeah, and one more thing, maybe let's just print out the password. Yeah, that would be more understandable for us. Let's show the password. So if we type correct password, we can see that the new password is correct and it is assigned. So that's fine for us. If we provide the password which is too short, then it shows us that the password is too short and the value of the password is not assigned. So using and this is maybe the most clear usage for private attributes. Basically, as I already said, we should not allow to directly access or change the attributes from outside the class. And that's true. And as an addition to this point, using the private attributes, we can use, I will check here, the common approach, not common but usually used approach for the private attributes is that the attribute is defined as private. Also protected, but maybe let's keep private at the moment. We'll talk about protected access modifiers a little bit later. But for the private, the attribute is defined as private. But we also have the methods, public methods. Public methods. Using, and we can change or read the private attributes using them. So we have private attributes, but we have public methods from which we can access these private attributes. And as an idea, as you can see here, we have private attributes, but we have the public method from which we can enter the password. But when we enter the password, we actually have to check if the password is correct or not. If the password can be used or not. So in this case, before. This case, the password must be validated before we assign it to the variable, to the object's attribute. So using this approach, like private attribute plus public method, we can add the validation to the. We can add the validation. We can add some adjustments, like we can adjust the value in some case. We can calculate the value in some case. Like we can also do the password plus something like that. Why not? So we can add some additional calculations here. Also, calculations, some adjustments, some corrections. We can do before we actually assign the value to the attribute. So that's the one of the key points of the restrictions of the accessing to the attributes. Yeah, we can use the public methods to have the correct access to them, because if we don't have, if we don't have the private definition here, in this case we could simply change the value here. We can put the value whatever we want, and the value would not be validated. Yeah, so if it's not private, then we can easily change it, we can easily access it, so we can create any mess we want. So in this case, that's not what should we normally do. When we write the program, when we build the classes, like again for previous I mentioned, so let me again mention the same thing. So JSON or XML, it would be XML. For XML we have strict process, we have strict methods with the strict properties. So all the properties are strict. You cannot basically, if you have XML file, you cannot. Let me just open one XML file, for example. A moment. We'll open it. So imagine we have XML file with the correct format, some specific format. For example, like in Java, we read these XML files. We create the objects for teams. For each team, we can create the object. Then it's obviously that when we write the program here, we use Java built-in libraries for XML documents and document classes and so on. Then obviously for these documents, what we should do, we should only be able to read the values from the XML file. We can get the attributes of the XML object. We can get the attributes, we can get the nodes, subnodes, and so on. So in theory, that we should not, right here, if we use these XML files, we cannot just directly change the structure of XML files in the way that we just add some text in between, because this will actually destroy the format of XML. So we should normally, when developer works with XML files, then developer should not worry about the structure. Developer just only wants to build these XML documents, add some nodes, change some attributes, and read all these attributes if it's needed. So the the developer should not normally destroy the structure of XML document, as an example. That's why we use encapsulation. We adjust the access to the attributes. We control the access of the attributes, so that helps us to build more correct programs and to work with them in an easier way. Alright, let's have the break now, and after the break we'll continue talking about the classes and objects. Okay, let's move on. So let me just have an introduction on encapsulation. We talked about private attributes, in some cases where do we need to use them, how we can use them. So right now let's one more minute, just about at 36. Okay, let's wait half a minute, see if there's someone who's outside and will join us in 20 seconds. I'm just to not start earlier. And I promise to start. It's a little bit, 20 seconds, and then we can start. Continue. Okay, so I hope everyone is back, so let's continue. So yeah, that's about the encapsulation, the introduction of the encapsulation. We can have different ways to access the attributes, different restrictions to access the attributes, and the methods as well. Yeah. The same as for the methods, we can define the same for the methods. Yeah, for the methods we can also define private, if needed. So we can define private method. For the private method, the concept is the same as for the attributes. You can access them only from inside the class, and the usage is also similar as for the attributes. Yeah, that's basically for the private methods. We use them just. For me, private methods, private instance methods is the first option. Yeah, when I think about what kind of access modifiers must be, because it's like if I'm inside the class, I just do some stuff inside the class, and if my stuff is not meant to be used somewhere outside the class, yeah, like the method can change something, adjust something, and I definitely know that the method is expected only to be called from inside the class, and just like some calculations, some stuff, and so on. Then I declare it as private. And the concept is the same. Yeah, if there's something the same as for the attribute, if there's something you don't normally want to allow to be called directly. Yeah, like if there's some sensitive calculations, for example, sensitive changes, you do not want them to be done without any checks on the if that's data sensitive, then there may be the check on your user. Yeah, if your user has necessary authorizations to access some sensitive data, so that can also be used. Yeah, like if you, for example, have a database and you read something from the database, you want to read something from the database, and then you have the method which actually reads the data from the database, but basically before the method is called, you have the method read database, which just only reads the data from the database. Then before that, you should have the method which checks the authorization. For example, for your user, if your user is authorized to read the data from the database. And then firstly there is a method which is public. Yeah, maybe then inside this public method you will have the authorization check, and if authorization check is fine, if you are authorized, if your user is authorized to read the database, then this method will call the private method read database, which just actually reads the database. Otherwise you will get some errors, for example, or some messages that you are not authorized to to access the database, in the sense the data from the database, as an example. But again, the concept is quite similar as for the attributes. But we'll talk about a little bit later as well. That's just the introduction of the encapsulation. So the next one is the question how to create an object. We already know that we need to call new. We need to write new keyword. New keyword. This will create as new object. Yeah. So that's basically the only way we can create the object, only using new keyword. Yeah, without new keyword, the object, well, there's no way the object can be created. So, yeah. And for the string, as for example, we can assign string directly by passing the string, the value we want to assign. Or we can the same way call new string, and this will be the same approach as used for all the objects. We type new, then we type the class name, and the object is created. Yeah, so that's the way how we create the object. So, and what basically does it do? Yeah, new operator allocates memory for new object and returns you the reference. So once the object is created here, it assigns the reference to the variable, which actually points to the location in the memory where this object is located. This is an example. The address is 123. For example, you can see here, and it's reserved to the variable. For the variable name was the value John. So we have the set on characters as an example. And basically the question for me may be why do we put something inside the brackets? What is it? And when we create the object, actually firstly the constructor is called, and to see how it works, let's create awesome constructor. I'll name it as constructors, and then let's have class person, for example. Then each person must have the name. For example, let's just simple person with the name. And again, we can declare it as private. Even more, we can declare it as final. Okay, in theory, the name can be changed during the lifetime. Okay, let's keep it not final. That will be the string. String name. And basically, is it possible to have the person without the name? I think no. I think each person should have the name. Yeah, it's like if we have a simple person have a simple way to create the object, then we just simply create the person. And what we have here at this point. At this point we created the person without the name, because at this point, when we create it, the person does not have the name, which is not really correct yet, because we have the object. At this point we have the object. At this point we have the object of person, but there is no name. Yes, and which is not really correct at this point. So how can we basically, I will write the question, what can we do to not allow the object to be the object of the person to be created without the name? What can we do? And the answer would be, first of all, for all the objects, to create the objects, the constructor is called. So what the constructor is? Constructor is the method which is called when the object is created. So basically at this point, when we call keyword new, we create new object, then at this point the constructor method is called. By default, constructor method is just initial. That's the method with no object. But what we can do, I'll type it here. By default, first of all the classes have the constructor, and it is the method without any object. So as you can see here, basically that is what we have by default. There's the constructor with no object, just person, it's called, no object here, and that's it. How do we define a constructor? We have again access modifier. Maybe let's just talk about public constructors, because there is also a possibility that there are private constructors and private constructors, which actually mean that the instance of the class cannot be created outside the class. But this is not quite complicated, but maybe more tricky scenario. Let's not talk about it now. Let's just work with public constructors. For the public constructors, and the most usual case, we have public constructor, and the syntax is that there's public keyword, and then there is the class name. The class name with the circle brackets. You cannot create the public void public sorry, not public person. So, person. Okay, you can, but in this case, constructor will have the same name. The syntax is that there is no void, there is no returning type, just person, just class name. So the syntax is syntax for all the constructors. Access modifier plus class name plus brackets. And basically the same as for the methods. And there's no returning type and no void. No returning, no void as well. So that's basically the constructor. Just the method which is called when we create the object. Then maybe just for the clarification, I will print out that constructor is called. So here we create the person. As you can see, once the person is created, constructor is called, and the logic here is triggered. Let's just to understand it, but the constructor will be called. Yeah, and let's go back to our issue. What can we do to escape this option to be done, that we create the person, but the person actually, the object does not have the name. So to solve this solution, as I said, and I also, just if you go to the head, I will also have the arguments here. Yeah, the idea is that for the constructors, we cannot have any returning types, but what we can do is we can have the arguments. And yeah, so if I have the argument, I can use this argument and I can assign the name for this name. Yeah, so at this point, this is the constructor which asks to enter the name value before we use the object. So at this point we cannot create the object in the way we did before. So we cannot do it anymore because we have the constructor which has the parameter. So in this case, so check here, if constructor does have the parameter, you cannot create the object without providing it. So now you cannot just simply create the object in the same way we did before. We must provide the name. So let me just check and so on. So right now we have the object. The object will be person. Okay, the person, and once the object is created, we'll have the person which has the name. So at this point, when the object is created, the object will definitely, the person, just write them both, will definitely have the name. So actually we cannot escape entering the name. That's the idea of constructors. Yeah, the same way we can provide multiple attributes, like again, string surname, same way. Maybe also tap it here. And I can also provide the surname here. And yeah, but here you can see there's the error. Surname. Now again we have the error because we have not provided the second argument. Type the surname, and right now we have the person with the name and the surname, and we are 100% sure that these parameters will be added, will be provided. So in this case, the summary for the constructors are that these are the initial parameters without which we can, and without these parameters required in the constructors, we cannot create the object. So there is no option we can create the object without the values provided. That's the idea. And the same for string. Yeah, you cannot. Yeah, the same for string. We cannot create the string object without the value. It also makes sense, yeah, because even if there's empty space, I mean not empty space, but just empty string, that's also the object. That's also the value. That's also the value. But if we provide nothing, maybe let's just quickly also write it for string. Yeah, simply string, and we just simply write for string. It doesn't. Okay, it allows us, but yeah, actually, okay, that's interesting. Let's check what we have idea in the result. I thought that would provide us the error. Okay, let's see. I think it automatically. Okay, let's see what does it create. Okay, there's just empty string. Okay, that's okay, that's fine. Okay, that's fine. But again, the idea is that we should normally have. Okay, that's not empty space. That's just a string. But okay, the idea is that for the strings, if we want to normally use them, we should provide the value to the constructor. And that makes sense. Like again, for the person, you cannot create the person without the name. You cannot create your user without the username and the password, for example. Yeah, all the mandatory parameters that must be provided before the object is created must be provided to the constructor. Yeah, and as I said, the syntax is that constructor should be the same as the class name. And here's the example. If we have the computer with the values, with the attributes here, then there's constructor. This is non-argument constructor, and this is argument constructor. Basically what we can see here, there's so-called thing like method overloading. Yeah, but we'll talk about method overloading a little bit later. Yeah, that's maybe topic a little bit heavy. And so at the moment we haven't talked about method overloading. But yeah, for the constructor, again, you can define a constructor as non-argument constructor. Also fine. By default, it is non-argument, and even without any code, yeah, that's by default. You can write your code under the constructor as an example. Yeah, if you have an initial constructor, for example, if you have maybe I will not write it here, I'll just tell. If you have, like, you create the file. Yeah, imagine you create the file. Yeah, you use Java code to generate some stuff for the files. Yeah, and maybe for the files, yeah, one of the key properties may be creation date. Yeah, for example, we have creation date for the files. So in the constructor, without any parameters, we create. We just create a dummy code here. Yeah, so pass file, and then we have something like date created at. Then using the constructor. I don't need to provide any attributes, we just give them this. Yeah, let's be latest. That's just dummy code. That's not the. That's not the real code. So and here I just provide something like can be, yeah, maybe I type something. I get system, and there should be current time, for example. Current time, what else do we have here? Current time, that should be fine as well. Yeah, maybe if we have time, yeah, just this matter. So at the moment the file is created, the system reads the time, and then we assign the time just to make it errors. Okay, that's wrong. That's wrong. So we have the class file. We create the file, for example. Then the file is created by Java. I create the object file, and at the point the object file is created, yeah, the constructor reads the fixes and the time at which the file is created, the object is created. Then this time will be fixed, and this will be stored under the object. So as an example, I'll write it here. Just I will default this. I want it. At the moment, the file object created. The system is taken and stored under the object. Yeah. So that's one of the usages when we can have an unparameterized constructor but have some logic inside. Okay. So that's it. And of course, as we already mentioned today, you can have multiple parameters for the constructor, and we can use these parameters in some way. You know, for example, to assign the attributes of the object. Yeah, so without the arguments you can assign any values, for example, as well. Why not? Using the argument constructor, and if there's at least one parameter, you'll need to define these arguments as well, the same way as for the methods. Arguments are defined in the same way as for the methods. We have the sequence of the arguments, we have the types of the arguments, so we must start with type. There is the argument name, variable name, and then we can use these arguments inside the method. And yeah, as an example, we can use anyone. Constructors, yeah, if we have multiple constructors, we can use anyone, but again, this is the topic I would like to talk a little bit later, because this is related to method overloading, and the methods and constructors may be overloading, which is golden. And it basically means that we have the methods and the constructor or the constructors with the same name, but with different arguments. We can have the same method with the same methods with different arguments. And in this case, different logic will be used as well. But we'll talk about overloading a little bit later. So yeah, and the constructors. If we go back to to our example on the computer. Maybe let me just let me just copy it, and I will rewrite. Let me access computer 2. That will be fine. So for us, let's stick it here. Another class element. Not use it. So what we had in the method in the class computer, we just assigned the values directly from the code. That would be fine in some cases, but maybe again let's use different approach here. And if I define a private, I can actually use private, then model. Okay, since we are located in the same class, I think, okay, let's do maybe a different thing. Computer. I will just this way. Then I will close this class, and I will create some class computer. Right here. And I will move this logic to main. So I just want to show you that we are in different classes. Yeah, so if we call this logic from different class, computer 2, but from different class. Then okay, from different class, then we can see that we cannot allow we cannot directly access private attributes from different class. So since we have these attributes defined as let me just delete these. That is, we don't use them at the moment. So I'll also go over here. This is already in that file. You can check it. So yeah, what we have here, we have two classes. We have one class and we have another class. So we have class COMP, computer, and we use this class in class computer 2. So yeah, and as we know, we cannot access private attributes from the other class. Just in this case, what we did before, we just assigned the attributes directly, using the attributes. Another approach would be to use the constructor, to use Parameterize Constructor, where we can define these attributes. And then we will pass these the values to these attributes using the constructor. So that's also an approach usually used in string. And from the constructor we can just assign these values. So let's start right, and yeah, this is the point where we need to use this keyword because weight is the parameter defined here. That's why we need to use mandatory need to use use this keyword. And yeah, same for all the other attributes. Color equals color. Then and equals then the screen size equals screen size. And the price equals price. Yeah, please remember that the sequence is not important here. Yeah, you can just assign them in any sequence you want. Because it doesn't matter, they just go one by one. And what we can do right here, we do not need to see if we delete it. Oh, let me try. Okay. So, instead of just simply assign the values directly, we can pass them to the constructor. So that's 12, that's 100, that's 16. And at this point, the sequence is important because the parameters must be the one provided, the same as provided here. And yeah, so that's a mistake. I just done. Sorry. Okay. So let's check the price. Screen says weight. Oh, okay, let's weight from. Okay, let's adjust the input. So we have weight. The first one. There's RAM. Second position is correct. Screen size 15. That's correct. And then color. Then we have price. Okay. So yeah, please remember. Here. Please remember to put the attributes in the correct sequence. So that's important. Otherwise, you will have the wrong values, and in some cases the program will not be even compiled. You'll have the different type which cannot be casted directly. Okay, so for the second object, let's do the same way. Let's pointer, then the screen size, and then run 32. Screen size is 15. Price is 100, and the color is yellow. Okay, so in this case we don't use to assign the values anymore. And yeah, so now let's print out. And yeah, we can see that the result is the same. The only difference is that here we provide all these attributes to the constructor. So I will click here. The result is the same as in the class constructor. And the only difference is here all the values are provided using the constructor. Alright, so that's the introduction about the constructors. Yeah, and if we go to the methods, yeah, we already used the methods right here. Yeah, they can be the voids, yeah, they can be voids, they can be the methods with the returning type. So, and that's a part of the code. Yeah, obviously, we write them in the code. We write them inside the class. Yeah, we cannot for all the methods we cannot write the methods outside the class. That would be that's not correct, obviously. Cannot have the method outside the class. The methods must be inside the class. Yeah, and the purpose of the methods is to perform some specific task. Like in this case, the purpose of the method is to display the attributes of the object. And for each method, there is a separate task. Like the same for this method. System.print1, that's also the method. If you go inside, you can see that that's the method, print line. The purpose of the method is to actually print the content we provide to this method, to this attribute. And same for this one, print, also print. Yeah, that's one for the scanner. For the scanner as well, method read next line. Purpose is just to read the line written on the console. Yeah, so that's the purpose of the methods. And the characteristics of each method can be, you can return one or no values using return. We'll talk more detail about it next time, but at the moment I'll just quickly introduce you. Returning type. Get int value, some integer value, and here we'll return some integer value. So that's the method with the returning type, integer, and at the end of each method, which has the returning type, we must return something, and if there is a returning type. So that's using return keyword. Again, as you remember, if we have void, we cannot return the value because there's no type provided. But for the voids, we can just simply type return without any value. It means that, again, as you remember, we'll just simply get out of the method. We finish the execution of the method at this point. So that's quick mention. We'll talk a little bit more deeper about it next time. And then what else can we have? We can have the amount of we can have the parameters. It can be 0 to unlimited. Of course, please don't declare too much parameters, because if you have too much parameters, then you won't be able to capture the sequence of them, to follow the sequence of them. If you need to call the methods with many parameters, then it would be quite complicated to provide all the parameters in correct sequence. So that's why that would be a good idea to have unlimited number of the parameters. So just in a way that would be understandable and comfortable to use for the developers. And the characteristics, returning type, the title of the method, and input parameters, or just parameters inside the methods. So when the method will finish the execution, it goes back to the method. It is called the method called it. So usually we use main method. We start in the main method, and then for example, let's go right here. Right here we go to the method display attributes of the object. So we go here. The method does its stuff, and the method finished its execution. It goes back. So this is called the call stack. So when we are here, we are on one stack. Okay, maybe let's quickly check if that's possible to see from the debugger. I guess that should be visible. One moment, so let's quickly check it. So yeah, from debugger, I guess okay, it's let's quickly check. Okay, let's do okay, if we go into, oh yeah, here you can see we have support thread or call stack. We have starter method. Then we go inside. We are on the next stack. So this is called call stack. Here we are on this stack, and here we are on this stack. And once the program does all its stuff right here, then it finishes its execution and goes outside automatically. So that's normally that's how it is done for all the methods. Or if there's somewhere in the middle of the method, as you remember, return keyword. It means that the method will be. Let's just add some logic and just to make it compilable. Maybe color is say color equals some random stuff here. Yeah, maybe we can have return statement in the middle. It means that the program will be the method will be will stop the execution right at this point. Yeah, this code will not be executed. Okay, somewhere in the middle there is return statement and it is executed. As you remember. So using return statement we can finish the execution of the exact method at the point we want to finish. Alright, so let's see what we have ahead. Okay, maybe let's stop at this point because this will require more time to discuss. So I think we can start talking about static instance methods. Next time we already had some. I already mentioned some things about them today, but maybe just to make it more clear, I will talk more about them, about these methods, and maybe let's just do it on Friday. So we also have more time to discuss all these things. Okay, for today, thank you for your attention, and meet you all on Friday.